In this video, we are going to talk about Z distribution or Z distribution. The objectives of the video: understanding the properties of Z distribution. At the first phase, we are going to understand what are the properties of Z distribution, and next we are going to learn how to read values from standard normal distribution table. Okay, this is the shape of the normal distribution, and there are many examples that we can get as normal distribution things, just like you are going to measure the height of male in a particular state. So then you will have different height values. If you are going to put your different height values in x direction and number of people belongs to each height into the y direction, then you will have a less amount of short people, most tallest people another less amount, and averagely it will have high amount of people between these area. So that is an example for data set that is going to be distributed normally. So this curve is also called a bell curve, and it has a shape just like a mountain. Okay. First, we are going to see what are the properties of this distribution. Okay. Mean of the distribution is 0 and the standard deviation is 1. Okay. So, mean. You know that mean is denoted as mu. Mu is equal to 0 and sigma is equal to 1 for this distribution. Mean is in the middle of this graph, and then you know that when it is 0, left side of this graph will have negative values like -1, -2.5, -3.48, something like that. And the right side of this graph will have positive values like 1.1, 2.32. Now, the area under the curve is 1. That means the total area under this curve, is equals to 1. If I color that one, yes, the inside the graph, okay. So the total area under this curve is equals to 1. The next property is the graph is symmetric about the mean. Okay, what does that mean is something like this. This side area, okay, and this side area are equal. Both are equal. That means if the total area under this curve is 1 and the graph is symmetric about the mean, so the area left to mean is 0.5 and area right to the mean is 0.5 because the graph is symmetric about the mean. Okay. Let's look at the following graph. Okay. The question is, what is the area of the white part of the graph or the uncolored area? What is the area of this uncolored part? How can we find that? Only we have given a colored area, green colored area, by denoting that the area of that part is 0.38. Okay. Now what we know? Already we know that the total area under the curve is 1. Therefore, the remaining area can be taken 1 minus 0.38 because since the total area under the curve is 1 and the left side area is given as 0.38, then we can reduce that part from 1, then 1 minus 0.38 which is 0.62. That is the area of that right side white part or the uncolored area. Okay. Now, standard normal distribution table. Okay. This is the one part of standard normal distribution table. At the beginning, you can see that they have mentioned something special, standard normal distribution. Table values represent area to the left of the Z-core. Okay. The first column has some value, negative values, and up to only one decimal place. And the first row contains another set of values and it has two decimal places. So, and there are some other values inside the table other than that column and the row. Okay, these values. So, what does that mean? Okay, the area values are these. These are the area values. Area of the graph. Okay, different area values. And these are the first column and the first row together gives the particular Z value for each area. Okay, now look at the value. Look at some value. Now look at this value. This is 0.00317. 0.00317. It is in this row, minus 2.7, and this column. So, the particular Z value for that one is minus 2.73. You just merge this first row values at the end of the first column value. Just merge it. So, in that way, what is the particular Z value for this one? Okay, the row is minus 2.0 and the column is 0.06. That is then minus 2.06. Good. Now, what is the value for this one? What is the Z value for this area? That is minus 0.33. Yes. Now, why they have told that area left to the Z-score? What does that mean? Can you see this symbol? You know that the horizontal axis shows the Z values. So, and you know that the middle is 0 and the left side is negative values and the right side has positive values. Okay, so can you see that they have colored a left side area to some Z value? If you can see that Z here, very little Z you can see there because I have used a very small figure here. However, you can see that the left side area colored. This table gives some values for normal distribution when you take only the left side areas. Okay, now what does that mean is, think that you are going to write down a negative value here. Let's take minus 2.23. Okay, now let's go to the table and find out what is the area left to this value. That is what we can get from this table. Okay, now minus 2.2, okay, it is here, and 0.03, okay, it's here, this column. So, the area left to minus 2.23 is the area that we can get from this table, that is equal to 0.01287. But we cannot get this area directly from the table. Only the left area it gives us. Okay. Area is a probability value. Okay, the area is a probability value in the notation format. How we can write that? According to the probability terms, of like in probability statement as a probability statement. So that is, consider -1. So how we can take the value over here? The area the area left to -1. Okay, let me color that area first. Okay, this is the area. You know that we can take this area directly from the table because the table directly gives the left side area values to some z value. Okay, now our z is -1. Okay, so how we can write down that one is this probability that z less than -1. That is the area. Okay, probability that is going to be less than -1 is this one. That -1 is -1.00. So it is this one, this value. So this area is 0.15866. Now 2.5 minus 2.5, and how we can write down that probability z being less than -2.5. Z less than -2.5. That is the area of this one. Okay. Now we should go to the table -2.5. Okay, this one -2.5 means -2.50. So the first column, and this is the area. So this area is 0.00621. Let's find what is the probability z less than 1.2. You know that the middle is 0 and the left side is negative values. Left side has negative values and the right side has positive values. So these are now positive values. Even for those positive values, you can get the left side value, left side area values. Okay, let me color the area first. Okay, so the area less than 1.2. So this is the other part of the table. The right side you can see a table, that is the other part of the standard normal distribution table. So, and you can see the symbol, graph symbol given by the table. It is similar to something like this, what we have drawn here. So still how to find the z value and the thing that these are the area values and all the things are same. Only change is the positive values. This has positive values and the other one has negative values. Okay, now 1.2. Here it is. 1.2 means 1.20. So the first column. So this is the area. You know that up to 0, from left to 0, this is 0.5 up to 0 because of the symmetry, right? Symmetric property. And then it has some another amount to add. Totally that area is given by this one, 0.88493. Okay, this one is 88493. 2.3. Okay. Now, next we want to find probability z less than 2.58. Okay. Now, 2.5 here, and we should get the remaining 8. Okay. This is the column. You see that it includes a larger area than 1.2. So, the total area for that one is this. It includes that the previous area, probability less than 1.2, right? And this area, this is the total area for probability z less than 2.58. Okay. Now, that value is, we got that 0.99506. Up to now, we found only left side values, but sometimes we need to find the right area. However, you know that we cannot take any right side value from the table directly because the table only supports for left side areas for a particular z value. In order to find out the right side area for a particular z value, we can use two methods. The first method is taking the particular left area using the table. Okay. So, in order to find out this area, first we go to the Z distribution table where we can find areas to the positive values and then find the particular area, left side area for that z value, and we are going to do this calculation. What is that calculation is probability z greater than 2.34 is equals to 1 minus probability that is less than 2.34. Probability z less than 2.34. We have to find out this one from the table. You know that we can take that area from the table. Okay. Let's go to the table and find out what is the area less than z equals 2.34. Okay. Now, let me go back to the table. Up here, 2.34. Okay. This one is 2.3 and yes, this is the 2.34, 0.99036. So, this value is 0.99036. This value. So, how to take the value greater than 2.34 is reduce this amount from 1. So, 36, then you will get 1 minus 0.99036, which is 9.64 into 10 to the power minus 3. It's a very less area. Okay, now I'm going to tell you something very interesting. Instead of going to the tables to find out the left area and reducing it from 1 and doing something extra work, we can just take the area right to some value using this technique. Okay. What is the way is using the symmetric property. If you remember that I told the middle is 0 and the left area is 0.5 and the right side area is also 0.5. In the similar way, if you take some value like 2.34 and consider the same value but negative, that is minus 2.34. Now, just consider that minus 2.34. So in order to find out this right side area, if you can find the area left to this minus 2.34, that is similar to this right side area to 2.34. That is the symmetric property we can use to find out such right side area to some z value. Okay. How can we write down that in P? Z greater than 2.34 is equals to probability Z less than minus 2.3. You know that this one just we can get from the Z table. Instead of doing this way is also correct. But instead of doing that one, we can just use this technique and find out the right side areas quickly. Okay, let me go to the table and find out what is the area less than minus 2.34. Okay, let me go back to the table. Okay, minus 2.34, minus 2.34. Yeah, this is the value. 0.00964. Let me write down that one. 0.00964. See, the same answer you can get.